Okay, this is the second part of lesson 22 before we get to the problem set. So I'm looking at problem C, 3 minus x over x squared minus 9. What I notice right away is that my denominator is in the shape of the difference of two squares, so it's x plus 3 times x minus 3. Now this is the part I really need you to focus on. We want our numerator to kind of look like our denominator so we can simplify some things out. We have a 3, we have an x. How do we get them to look the same? Well, if you agree that 3 minus x is the same thing as negative x plus 3, I just rewrote them in a different order. Now that's kind of looking like my denominator, sort of, but what if I factored a negative 1 out of there? So it's still going to give me the same value. Negative 1 times x is negative x, negative 1 times negative 3 is positive 3. So now I'm just going to rewrite my numerator as negative 1 times x minus 3 over x plus 3 times x minus 3, and those would simplify out. But remember, for our exclusions, we have to look back at our original polynomial expression, and the two places where you would have a denominator that equals 0 is at x equals 3 and x equals negative 3. Alright, for letter D, I'm just going to write it on a separate little whiteboard here. Okay. I have 3x minus 3y over y squared minus 2xy plus plus x squared. Okay. So looking at my numerator, I should be able to notice that I can factor 3 out of there of x minus y. And my denominator, that's a perfect square trinomial. That is y minus x times y minus x. So now our numerators and denominators, there's something similar about them, but they're not close enough that we can actually factor something out. So again, little thought bubble here. If you agree that x minus y is equal to negative y plus x, could I also not write that as negative 1 times y minus x? Okay, so when I distribute that negative 1, it becomes negative y plus x. So all I'm going to do is I'm going to rewrite that x minus y as negative 1 times y minus x. So don't forget there's a 3 out there. So negative 1 times 3 is negative 3 times y minus x over y minus x times y minus x. Those simplify, and I get negative 3 over y minus x. And my exclusion is y can never equal x, because then your denominator will equal 0. So our lesson summary is this. If a and b and n are integers, and n does not equal 0 and b does not equal 0, then n times a over n times b is the same thing as a over b. The n's would simplify out, they'd factor out. And the rule for rational expressions is the same as the rule for integers. They behave the same. But it requires the domain of the rational expression to be restricted. Okay? So the domain are like all your x values. Okay? There are some restrictions on what your x's can be. And those restrictions are no value of the variable that can make the denominator of the original rational expression equal to 0 is allowed. So those values that we excluded, that's what this is. No value of the variable can make the denominator of the original rational expression equal to 0. Okay, the next video will have the problem set.